Hello, everyone. Today let's know about the humidity sensors. First, let's delve into the characteristics of humidity sensors. Humidity refers to the amount of water vapor contained in a substance. Most of the current humidity sensors measure the water vapor content in the environment, which is usually expressed by absolute humidity, relative humidity, and dew point or dew point temperature. 1. Absolute humidity. Absolute humidity refers to the mass of water vapor per unit volume of gas. 2. Relative humidity. Relative humidity is the percentage of the ratio of the partial pressure of water vapor to the saturated vapor pressure of water at the same temperature in the environment to be measured. 3. Dew point or dew point temperature. At a certain atmospheric pressure, the air containing water vapor is cooled. When it drops to a certain temperature, the water vapor in the air reaches a saturated state and begins to change from a gaseous state to a liquid state and condenses into dew drops. This phenomenon is called condensation, and the temperature at this time is called dew point or dew point temperature. If this particular temperature falls below 0 degrees Celsius, the water vapor will condense into frost, at which point it is named as the frost point. Usually, the two are not distinguished and collectively referred to as the dew point, which is measured in degrees Celsius. Humidity sensor refers to the component that has a corresponding to the ambient humidity or converts the humidity into a corresponding measurable signal. The humidity sensor is composed of humidity sensing elements and conversion circuits and can convert ambient humidity into electrical signals. The main characteristics of the humidity sensor are as follows. First, the sensing characteristics. The characteristics of humidity sensors, such as resistance, capacitance, frequency, etc., vary with humidity. These relationships are commonly represented using curves depicting the relationship between humidity characteristics and relative humidity, as shown in the figure. Second, the humidity range. It represents the humidity sensing range specified in the technical specification of the humidity sensor, and the full range humidity is from 0% to 100% RH. Third, sensitivity. The sensitivity characteristics of humidity sensors, such as resistance, capacitance, etc., represent the degree of change in response to environmental humidity. These changes also correspond to the slope of the humidity characteristic curve of the sensor. Because the humidity sensing characteristic curves of most humidity sensors are nonlinear, the ratio of humidity sensing characteristic quantities in different environments is usually used to express the sensitivity of humidity sensors. Fourth, hysteresis characteristics. During the process of humidification and dehumidification, the absorption and desorption curves of humidity sensors do not coincide but rather form a hysteresis loop, which is known as the hysteresis characteristic. Fifth, response time. Under a certain ambient temperature, when the relative humidity jumps, it refers to the time required for the humidity sensing characteristic amount of the humidity sensor to reach the specified proportion of the stable change amount. Generally, it is calculated according to the time required for a 90% relative humidity change within the range of corresponding initial and final humidity levels. Sixth, temperature coefficient for humidity. The change in humidity sensor sensitivity per 1 degree Celsius temperature variation when the environmental humidity remains constant. Seventh, aging characteristics. The humidity sensor will change its humidity sensitivity after being stored in a certain temperature and humidity environment for a certain period of time. Then, let's delve into the classification of humidity sensors. There is a wide variety of humidity sensors, which can be classified based on their output electrical quantities into resistance-based, capacitance-based, frequency-based, etc. They can also be categorized based on their detection functions into absolute humidity-based, relative humidity-based, dew point-based, etc. Furthermore, they can be classified based on their materials into ceramic-based, organic polymer-based, semiconductor-based, electrolyte-based, etc. According to different materials, we will learn several humidity sensors. The first is a ceramic humidity sensor. This type of sensor uses its surface porous dilution to conduct electricity, thereby changing the resistance value of the element. The characteristic of this humidity-sensitive component, where its resistance varies with external humidity changes, serves as the basis for manufacturing humidity sensors. The second is an organic polymer humidity sensor. Commonly used are polymer-resistive humidity sensors, polymer capacitive humidity sensors, and condensation sensors. The working principle of the organic polymer resistive humidity sensor is that water molecules are adsorbed on the polymer film with polar groups. Under low humidity, due to the small adsorption amount, charged ions cannot be produced, so the resistance value is high. When the relative humidity increases, the adsorption also increases, and a large amount of adsorbed water becomes a conductive channel. The positive and negative ions of the polymer electrolyte mainly play the role of carriers, which reduces the resistance of the polymer humidity sensor. Polymer capacitive humidity sensors are manufactured based on the principle that the dielectric constant of the component changes with the relative humidity of the environment after the polymer material absorbs water. The dielectric constant of the element is the sum of the dielectric constants of water and polymer materials. The condensation sensor is made by taking advantage of the dilution of organic polymer materials mixed with carbon powder. Under high humidity, the expansion of polymer materials will cause the change of carbon powder spacing and the sudden change of resistance. Using this phenomenon, a humidity sensor with switching characteristics can be made. The third type is a semiconductor moderate sensor. This sensor has the characteristics of fast response speed, good chemical stability, and resistance to high and low temperature impact. In this lesson, we have learned the characteristics and classification of humidity sensors. You can search the information after class to understand the further applications of humidity sensors.